The workbench of a madman with a dog. Look at all those damn dog hairs, man. Oh boy. So, there's some nice opals here. Little ones, big ones. There's a big one. Okay, there's a big opal. Big. This is a small opal, a smaller opal. And today we're going to look at it. Oh boy, huh? Blow it up a little bit so that you can see inside the stone. Look at that thing. The idea of polishing an opal is to have the surface of the stone disappear when people look at it so that it doesn't interfere with the light passing into the stone or coming out of the stone. Now, what you see here, there's like striations in the play of color, and that is structural inside the stone. It is not scratches or anything like that. It's part of the way the stone is put together. And those are honeycomb, the beginning of honeycomb, at the interface between two layers. The black crystal layer up above and the gray, green, whatever it is, potch layer down below. We call cutting like this potch back. Having potch backs are common in lightning ridge opals and meant to be dark opals, and everywhere else dark opal happens. It's a common thing because opal forms in layers. Because the stuff it comes from, which is volcanic ash, to start with, so it goes up in the air and comes down in most places, like Australia, right, or Indonesia, but not this place. This came from the Tsehe Mewucha deposit in Ethiopia, and that is a volcanic vent. It's the big throat of a volcano, right? Big round hole in the ground that has volcanic ash filling it. When you look at pictures of the things, people come marching up to it, and it's this big old round hole filled with white kaolinite clay. What happens when it weathers, when volcanic ash weathers, it turns into kaolinite clay. Kaolinite clay is what opal comes from. It's a very simple mineral. Half of it is aluminum oxide in a layer, okay? So the aluminum oxide happens in one layer with crystalline structure almost. It holds together as a layer, and a layer of silicon dioxide in tetrahedrons. Okay? One silicon atom and 4 oxygen atoms at 144 degrees from each other. Okay, so they are the way that silica is stable. Silicon dioxide is the most stable combination on the planet, and in fact, it's silica in one form or another is 73% of the planet. There's a lot of it. Okay, so, and it's stable. That's why there's a lot of it. And so this layer of silicon dioxide, during opalization, the aluminum oxide goes away. And it leaves this layer, like a postage stamp, of silicon dioxide. And this process is set off by the presence of iron oxide or iron sulfide in the solutions that are depositing secondary minerals in faulting and geological activity, okay? So in the secondary mineralization phase, these sulfide solution is introduced to the clay along with hydrogen peroxide from rainwater or artesian water. Okay? So I don't know anything about Ethiopia. Now, I have not been there. I have seen pictures of it. I see it in satellite pictures very clearly from Google Earth. And from that, and from my knowledge of geology, I can make some assumptions, but I don't know where the hydrogen peroxide comes from over there. Other than rainwater, okay? It always comes in rainwater that's had thunder and lightning in it. That's how hydrogen peroxide forms naturally. And we find it also in artesian water. So, like in Australia, there's a big reservoir of water under the Great Basin of artesian water. And all of the opal deposits occur around that. How about that? Cool, huh? So, that's quite an opal right there. It really is. And the Ethiopian opal got a real bad rap with that dyeing thing. And if anybody wants to talk about that, I would be glad to. But I don't want to argue with idiots, with people who don't know anything, who think, oh yeah, I saw 37 black opals from Ethiopia, and they were dyed. Somebody told me they were dyed. I will tell you how dyeing is lying. Somebody quoted Mr. Justin Thomas, and I think that the lies about black opal being dyed in Ethiopia came from that man, Justin Thomas of Black Opal Direct. And he has good reason, doesn't he, to want to keep all the riches of black opal buyers in his own court. Because this is better than most of his opals. And they come out of Ethiopia And people are giving them away now because they think they're dyed. And he still sells his for $5,000 to $10,000 a carat. Now, why do you suppose he might want to lie?